80 miles, and a viewer height of roughly 20 feet gives us a target hidden height of a whopping 3,703 feet.
Physics and logic on a level supreme. It's a curved reality, splitting flerf dreams.
Hey folks, how's it going? Curious UK here. So this video here coming up was something sent to me by a good friend, Gene Techman, and it's a video done by Taboo Conspiracies, or Taboo Conspiracy 2, I guess. It's the second channel, don't know. And it's an observation of Milwaukee across one of the Great Lakes, and they think this proves the flatness of the Earth. Now I do question something, and obviously these guys don't like to question stuff. Why was this on the news and seen as a kind of a rare occurrence? That's something that actually ended up on the local news where somebody took a picture. If the Earth is flat, then this observation would be a nightly thing. It wouldn't be newsworthy, and you'd be seen this is a very common occurrence, and you can assume to go out there any single night of the year, anytime you want, take this picture, and it'll always show up. But somehow this one was a rare occurrence and normally can't be seen. So there must be something else going on here. Something that Gene Techman and Taboo Conspiracies don't understand. And why this is a very rare occurrence that happens sporadically sometimes, and somebody happened to have caught it this one time. Let's look at the video done by Taboo Conspiracies that's been sent to me by Gene, and we'll break it down later, and I'll show you what was actually going on and why this doesn't actually prove the flatness of the Earth whatsoever. Let's get into it.
This is Taboo Conspiracy 2. I wanted to first thank Mike Bull for pointing this out. This is a picture of Milwaukee all the way from Michigan. The photographer took the picture with only a Samsung Galaxy S7 using a 10-second exposure and ISO of 400. According to Fox News, it was a distance of roughly 85 miles. However, I would say that the distance was probably around 80 miles as shown on this Google Earth map.
Ah yes, nice. Google Earth map. So, in other words, you're using the globe to figure out your distance. Good job.
80 miles and a viewer height of roughly 20 feet gives us a target hidden height of a whopping 3,703 feet.
Hold on, that seems to be doing obviously very basic distances there, because we're looking at a optical observation, being that the lights across that Great Lake, they're looking at Michigan. So where's the calculations for the refractive index of the atmosphere that you're looking through? Because, well, we live on Earth that has an atmosphere, and the atmosphere actually does affect the path of light. So where's the calculations to calculate the refractive index? Where's the calculations to show the temperature gradient, or even what temperature was even taken at the site where you where the picture was taken from? I mean, where's any of this? Because this is important when you're looking at optical observations, to try to look for the curvature and stuff like that. So where are these? Oh yeah, that's right. Flat earthers don't like to bring those up because, well, they tend to falsify their flat earth, now don't they?
But the tallest building in Milwaukee is only 601 feet. That means that the top of the tallest building in Milwaukee should be 3,102 feet below the horizon.
Okay, cool. So, once again, show me that picture, and then show me the images of the buildings that you claim you can see. In fact, if the Earth is flat and you look across the water, you should be see all of Michigan. So, well, use your super fantastic P1000 zoom. I suppose this guy was using the Galaxy S7, so not the best zoom, but whatever. But you should be able to see all of Milwaukee. So you should be able to see all the lights, all the street lights, cars, the beach, everything. So, and you can see a few lights there, but show me the building. Show me the image of the building. So, I don't know, if I want to fly right there, go out there with your fantastic P1000, P1100, P950, whatever you want to use. and then stand exactly where he was standing and show me all the buildings, right from top to bottom, the streets and everything. Zoom right in and show me this this building. And because we should see the whole entire building, we should see all the buildings, all different points like that, or all different sizes. So where are they? Because I don't see them in this image. Do you?
Does that look like that the top of the highest building in Milwaukee is 3,102 feet below the horizon?
Well, let's have a quick look here. Let's see if I can see the higher buildings, the lower buildings, all of them. I don't see buildings at different levels and stuff. In fact, all the lights look like they're straight on the horizon. I wonder why that is.
So, what is the nonsense explanation offered by the Ministry of Truth? Can you guess it? It's only a mirage. For some reason, I think I've heard that one before.
We do have a rare view of Milwaukee for you. It comes from the other side of Lake Michigan. Now check out.
Wait a minute, did she see a rare view of Milwaukee from the other side of Lake Michigan? A rare view. So this isn't seen all the time. So this is really proof the Earth is flat. You should see it all the time.
Check out this picture. It's of the city lights that were taken last Thursday night in Muskegon, Michigan, some 70 miles away from Milwaukee. So why does Milwaukee look so close? Well, scientists have a name for it, but it's best explained as simply a mirage.
And what you're seeing here is a mirage.
So a little background on this. I've been in a conversation with Gene Techman for a while. He loves to rage out in my my DMs, which is quite hilarious and a bit entertaining for me. Eventually I asked him for empirical evidence of flat Earth, and this is what he sent me. This is Gene Techman's empirical evidence of the Earth being flat, which, if you watch the video, that kind of falsifies the question in the first place. Because, as the lady said, this is a rare occurrence. So it's not actually empirical data. Empirical data means it can be repeatable and demonstrable anytime. If the Earth was flat, then that view of Milwaukee across Lake Superior would be there all the time. We'd be able to always see it. Every single night, they'd be able to see the lights, see all the buildings, and see everything across the lake without a problem. Right? To zoom in, you should see that all the time. But as it was stated, it's a rare occurrence. So that being said, that in a way falsifies the premise of the Earth being flat, because it would never be a rare occurrence if that was flat all the way across. But let's look into it and let's see what's going on here. Let's see if we can explain this using the globe and using modern science and what we know. Now, one thing is I'll point out, and I pointed out before, is we don't actually see the buildings in this. We don't see any buildings at all. We don't actually see the buildings. What we do see is dots, points of light. We see dots, points of light, but they're all sitting across the line straight on the sharp horizon. Now, in reality, a crisp, sharp horizon, that falsifies a flat Earth. You would never have a crisp horizon like that if the Earth is flat. It would simply keep going off and off and off, and eventually it would start to haze out. You see the land is ramping up. You just keep going, and you start going to more of a mist, and you start hazing out. You'd still see things, but to get hazier and hazier and hazier, and it'd go off into as far as you could, way off. Right? You would never see a crisp horizon. So the fact is that we see that on a clear day, clear night, crisp horizon falsifies a flat Earth, because that's geometrically, it's not how a flat Earth would look. And we know this because we know geometry. Right? So plain and simple, basic geometry. Crisp horizon falsifies flat Earth. But we see points of light, right? Now they claim, okay, different heights of the buildings, stuff like that. Cool, right? But we don't see the buildings. So let's just put that aside. For now, we don't see buildings, we see lights. So what would cause the lights from Milwaukee to be seen across that lake? Well, let's look into it now. They mentioned something about a mirage, and specifically, it's it's an atmospheric phenomenon called a Fata Morgana. I'm probably pronouncing it wrong, but Fata Morgana, which is essentially a mirage of sorts. But let's look into what a Fata Morgana is, and see if it perhaps can help shed some light on some of this. Okay, so first thing we did is I looked up and found a newspaper article talking about this. Lights in Milwaukee were seen Thursday night from Lake Michigan's shores of Muskegon. So here it is. This obviously isn't the shot from there. This is just a it's a regular shot from just the off the water. So late Thursday evening, stretching into the Friday morning, you could see the lights of Wisconsin from Muskegon shoreline. The rare atmospheric condition allows lights 80 miles across Lake Michigan to be seen, as if one was looking from one shore to the other in Huron Lake. As the reflected image fades and intensifies, magnifies at times by the layer of warm air resting over colder, denser air over Lake Michigan. It was as if an armada of lake freighters were on the line, in line off the shore of Muskegon, another undescribed as the string of jewels or necklace. But when looking out into Lake Michigan, there's no doubt that one is seeing the other shore. Actual lights, such as the red beacon of the communications tower, can be seen, not just the glow of the horizon. The lights appear to stretch from Kenshaw, Wisconsin to the south, on the south of Milwaukee on the north. At times, Riken, Wisconsin, was so brilliant that a lighthouse and navigational aid flashed in the horizon as if it was 10 miles offshore. Arctic smoke signals. Okay, so the mirage is caused by a difference in temperature between the water and the air. Back in 2010, Dan Howe described it as an optical illusion. The Marine Superintendent of the National Oceanic and Atmospheric Administration Great Lakes Environmental Research Station on the Muskegon Channel, Donahue, is a veteran Great Lakes mariner. He has said he has observed the phenomenon aboard lake freighters in Lake Superior and across the Singapore Bay. The Fata Morgana mirage is described as the American Practical Navigator. In the American Practical Navigator of the U.S. Department of Defense Mapping Agency, it is seen as a narrow band near the horizon, and atmospheric conditions distort the images between being seen. The visual effect can be observed on land or sea, day or night, according to the Federal Instructional Manual. The layer of warm air settling over colder creates an atmospheric duct, which acts as a refracting lens, and the images can be inverted. All right, so images are inverted. So what is happening to the light rays is similar to what happens at night with radio waves of certain frequencies, as when AM radio stations can be heard from hundreds of miles away. All right. So it seems like maybe a Fata Morgana, which is it's sort of a mirage created by a temperature inversion of the different layers above the water or even land, can cause a phenomenon like this, cause something like a duct, even if sometimes the image can actually be inverted. Now, this original one done by Taboo Conspiracies and shared to me by Gene Techman, you don't actually see any of the buildings and stuff. All we see is points of light and light. So if those images or those buildings were inverted, we wouldn't know. This was done at night, is what you're referring to, and you're just referring to the lights. So the lights, and the other way you put them, you're going to see those points of light. So let's look further into ducting and see if it explains a bit further and how this might actually have worked, and how it does work on the globe, on the curvature, and how we can see things that may be a little bit over the curvature with different atmospheric phenomenon like Fata Morganas, and ducting, which does and can happen in our atmosphere. Let's have a look. They mentioned in the article ducts, so let's look into it. The most spectacular atmospheric refraction phenomenon are produced by ducts. In terrestrial refraction, they produce superior mirages and Fata Morganas. In sunset displays, they produce Wagner's black strip and long-lasting subduct green flash. Here is a table with links to some of the pages that use ducts. In addition, there are discussions of the sunset transfer curves of the ducts in relation to ducts, to dip diagrams into the refractive invariant and the slightly more detailed induction to the ducting in sunsets. So there are references to ducts in all of these web pages. But this is a left This has left information about ducts scattered all over many pages. It is useful to have the basic information about ducting in a single location. That is this page, which is also has many detailed links. And the page is, you can see the web page at the bottom here. So a little history. Although the optical phenomenon of ducts, notably superior mirages and fatamorganas, have been known for thousands of years, the term duct wasn't introduced until the 1940s when the radar operators in World War II began observing returns from objects far beyond the normal horizon. This is called anomalous propagation. By the radar people, in meteorological optics, it is also known as phenomenon as looming. The textbook example of observations of the coast of Arabia by the 200 megahertz radar in Bombay, India, 1,700 miles away. Because their wave optical effects are important at radio and even microwave frequencies, these early observations were compared to propagation in the waveguide. So the word duct was a natural analogy. Here's a brief explanation from the earliest papers of the subject. In a non-homogeneous atmosphere where index of refraction decreases with height, rays of sufficiently small initial elevation angle are refracted downward with a curvature proportional to the rate and decrease of the index and refraction with height. If the radius of the curvature is less than the radius of the Earth, such rays, such as maximum height, are confined or trapped between the height of the Earth's surface. This produces a process referred to as trapping, and the region atmospheric within which it occurs called a duct, because of the analogy of the waveguide propagation. And here's the doctor, says M. Kunz, W.H. Bachelor, here's the reference. However, the basic phenomenon deducting were mentioned by Bout 1810 and 1836 and Rao 1882 and discussed in detail, and Kummer 1860 and Wegner 1912 and 1918 in the context of atmospheric refraction and mirages, all of course without using the term duct. Most recently, the word ducts has been adopted in optical literature as well. How ducts work? Because optical refraction depends almost entirely on the temperature profile of the air, optical ducts are only produced when there's a steep thermal inversion, in which the lapse rate is more negative than the critical value. Elsewhere, so near negative 1.1 degrees Celsius per meter for typical conditions. Elsewhere in these pages, I've used a rather mild inversion of 2 degrees Celsius between 50 and 60 meters height, whose lapse rate is minus 0.2 degrees per meter. It's nearly twice the critical value. Here I'll use the even steeper inversion of 5 degrees in the same interval of height to make the ray diagrams clearer. This is a diagram showing this. So the diagram on the left shows, which is obviously above, for example, that the heavy curved line represents the surface of the Earth. Just the lowest 100 meters of the atmosphere are shown. See a scale for the upper left of the diagram, with a vertical exaggeration about 100 times. See a horizontal scale in kilometers. The shaded band above the Earth's surface represents the thermal inversion of 5 degrees between 50 and 60 meters height. The three rays are traced in the model atmosphere from the position of the observer, placed 45 meters above the ground on the height scale at the left. The right end of each ray is marked with the ray's angular altitude at the observer in minutes of arc. 0 for the ray observers, astronomical horizon, and the rays 10 foot above the below. Notice that the rays at 10 foot and minus 10 foot are refracted inside the shaded inversion layer, but pass completely through it. However, the horizon ray is quickly bent back down when it enters the inversion, so that it returns to its original height of 45 meters. After about 24 kilometers, then the pattern repeats and the rays again enters the inversion and is bent back down near 36 kilometers. Again returns to the original height near 48 kilometers, and so on, and the ray is trapped or ducted. This ducted horizon ray has most of its path below the inversion layer, which means that the bottom of the duct is lower than the bottom of the inversion. The bottom of the duct is discussed in detail below. Clearly, even rays with considerable slope, though somewhat less than 10 foot, can can also be bent back into this region below the inversion layer and trapped there. The diagram at the right, which is obviously above in this one here, shows rays at 3-foot intervals in altitude for the same observer and the model atmosphere as below, while the rays at plus 12 foot and plus or minus 9 foot pass through the inversion. Those with slopes 3 foot and 6 foot at the inversion are trapped or ducted. You can see that the rays 6 foot from the observer height, which peaks near 8 and 35 kilometers from the observer, penetrate further into the inversion, i.e. closer to the upper surface, than those with 3 foot from it, e.g. minus 3 foot rays whose apex is near 23 kilometers. Also notice that the ducted rays also come together about 44 kilometers from the observer. The duct acts like a lens, focusing these rays into a crude image at its distance. This focusing effect produces a vertical exaggeration of images on the superior mirage. When the focusing is sharp, is greatly extended. Vertical images of objects near the exact imaging distance from the striated zone of the Fata Morgana. In discussing the trapped horizon rays of 45-meter observer, above we note that it is barely penetrating to the lower edge of the inversion layer, so the ray oscillates between heights of 45 and about 52 meters. All the other trapped rays in the second diagram pass through the observer's height, but don't reach the ground, so the bottom of the duct is somewhere between the observer and the ground. Just how low can a trapped ray go? This question is answered in the labels of these diagrams. The top of the duct is the top of the inversion at 60 meters, but the bottom of the duct is far below the 50-meter base of the inversion. It's at 22.8 meters for this model atmosphere. Wagner called the difference between the heights of the trapped top and the bottom of the duct is effective depth in his 1918 paper. The base of the duct can be found from the atmospheric model, its height at which produced NR, where Rn is index of refraction of air, and R is the distance from the center of the curvature of the atmosphere, has the same value as the top of the inversion. Producing NR is a refractive invariant for horizontal rays, at which at each height a plot for these values against heights gives the dip diagram. It's instructive to plot rays from every minute of arc to in altitude at the observer. That's the diagram at the left here, above, of course, which shows the lowest 180 meters of the atmosphere can see 3 groups of rays. As you can see here, 1. Those with altitudes observer of 9 foot and more can pass through the inversion without trapping. 2. Those that lie within 8 meters of their observer's astronomical horizon, which are all trapped in the duct. And 3. Those at least 9 meters below the horizon. Here the rays are -9, -10, and -11, which initially pass below their inversion, approach the ground, and then pass back up through the inversion without being trapped. Rays 12 foot and more below the horizon strike the Earth's surface within about 24 kilometers of the observer and are not shown. The ducted rays gradually get out of step with one another and fill up the duct. You can see this beginning to happen at the right half of the present diagram, compared to 22.8 meters height of the bottom of the duct with the height of the lowest rays at the region. The lowest level reached by the duct ray is the bottom of the duct. Finally, notice the big gap between the inversion between the 2 groups of rays that pass up through the duct. This is a region that's invisible from the observer's position. If radar transmitter where our observer is it can eliminate targets in this gap, so radar operators call this region a shadow zone. Optically, it corresponds to the zone of sky blocked by Wagner's black stripe. Now I could go on and on more about this, but I think we'll the difference between ducting optical and radial wavelengths is due to the water vapor's effect on the refractive index of the air. In visible light, water vapor hardly changes the refractivity of air at a fixed pressure and temperature, but the radial refractivity is strongly affected by R, line in the pure rotation spectrum of the water vapor. At 1.3 centimeters length, wavelength. At longer wavelengths, which include almost all radio and radar work, the refractivity is considerably increased by even the small amounts of water vapor. Consequently, while the optical refractivity of air depends mostly on temperature profile, the radio refractivity depends mostly on absolute humidity profile. As the amount of water vapor decreases with height much more rapidly than the density of the atmosphere in general, the radio refractivity gradient is typically about twice as strong as the optical one. So while the curvature of visible light is typically around 1/6 of that of the Earth's surface, the curvature of the radio beam is about 1/3 of that of the Earth. This means that radio waves need less deviation from average conditions to produce a duct compared to visible light. Besides differences in refractivity and the greater importance of wave optical effects of radio frequencies, one should be aware of another significant difference between behavior of radio waves and light. The ocean absorbs most of the light that strikes it, but it reflects the radio waves. So while radio waves can travel for thousands of kilometers in a surface-based duct, the analogous optical structure produces a superior mirage of the sea surface only a few kilometers away from the observer. It can also produce a false horizon with negative dip, i.e. what Hassel in 1960-64 called, you can pronounce that, or horizon surface. This is just the upper edge of Wegener's black strip when the lower edge is hidden by the apparent horizon. However, when this low sun glitter path is miraged in this way, particular mirages can be produced. Use the link to use the video. This phenomenon of a Fata Morgana of the sea surface is discussed in detail by Cyprian van der Wolf in his 2017 paper. So in summary, what's a duct? A duct is an atmospheric structure that traps rays within the few minutes of arc of their astronomical horizon so that they cannot escape from the atmosphere, but are periodically bent back down as to follow the curvature of the Earth. The bending is produced by a steep thermal inversion. The inversion can do this if its lap rate is more negative than the critical value, near minus 0.011 degrees per meter for typical conditions. So there you have it. Taboo Conspiracies video that Gene Techman showed me is not empirical evidence of the Earth being flat. In fact, it is empirical evidence of a atmospheric phenomenon caused by temperature inversions that can create either a superior or a Fata Morgana kind of a mirage, and is known as ducting, in which then the light propagation propagates off of the thermal layer that is created by the atmospheric conditions and is then bent down. So what we're seeing there is that, and also, what you're seeing there is, so the light is coming up and is reflecting off this layer and is being bent down more by this temperature inversion that happens. It doesn't happen all the time. That's why it's a rare event. Also, light, like those, light diverges from the source. All light diverges, even lasers, especially like the lasers you can buy from like eBay or from like Amazon and stuff like that, like the ones that regular people can buy, have more of a diversion, right? So a lot of times flat earthers try to use lasers over like long distances and claim you can see stuff, but really all they're doing is seeing probably ducting as well as a diversion. So this phenomenon here, you're seeing divergent lights and also seeing the lights themselves being reflected down due to the ducting phenomenon. So that's about it. That falsifies flat Earth. It's not any evidence of the flat Earth. It's only evidence of the curvature of the Earth and atmospheric phenomenon that can and does happen. Thanks for watching, and I'll see you again.
Stuff like that's why people quit flat Earth, dude. You know? That's why people quit, dude.